Hey everybody, welcome back to the channel. In this video, I'm going to do a deep dive into free response question number 2 from the AP Calculus AB exam from 2025. Question 2, another free response question in which you can use the calculator or Desmos. I'm going to model it with Desmos. We have the shaded region here. We want to find the area of R and show the setup for our calculations. Setup for the calculations would be the integral from 0 to 3 of g of x minus f of x. Remember, when you get the area of a region, it's always top boundary minus bottom boundary, and you integrate that. And here, the top boundary is not changing. Here we have the graphs of f and g. To get the area between them, we're going to do the integral from 0 to 3 of g of x minus f of x dx. You get 5.136 or 5.137. You can either round or truncate it for the full credit there. Part B, the region R is the base of the solid. For this solid at each x, the cross-section perpendicular to the x-axis. So we know our slice there is going to be a vertical slice going through the x-axis, is a rectangle with height x and base in region R. Find the volume of the solid, show the setup for your calculations. So for part B, the area of a slice in terms of x is going to be, since it's a rectangle, base times height. They said the height is x and the base is in region R, which is just g of x minus f of x. Then to get the volume, we would do the integral from 0 to 3 of a of x dx. Since I defined what a of x is right here, I can use it when I write my integral. If you just wrote integral from 0 to 3 of x times the quantity g minus f of x, that would be fine as well. I already have f and g in Desmos as well as the integral from the previous problem. The only difference with this problem and that one is that the x was right there to get the area of the rectangle. So everything else is the same. If I just put that x there, that will be the same expression I need. And my volume is 7.705. There we go. And part C, write but do not evaluate an integral expression for the volume of the solid generated when the region R is rotated about the horizontal line y equals -2. So -2 is right here. If I take this same region and rotate it around, if I take that slice, I'm going to get a washer. The outside radius of the washer is given by the top function, which is g of x, minus the axis of rotation, which is -2. So g of x plus 2. Little r, similar idea here, but the inner radius is given by the function f of x minus the boundary of, or the axis of rotation, minus -2. So you'd have f of x plus 2. The volume is going to be pi times the integral from 0 to 3 of g of x plus 2 quantity squared plus f of x plus 2 quantity squared dx. Part D, it can be shown that g prime is 1 plus pi cosine pi x. Find the value of x from 0 to 1 at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. So basically what this question is saying, find when the two slopes are parallel. So that's going to occur when f prime equals g prime. So we have to get f prime of x. F is x squared minus 2x, so the derivative would be 2x minus 2. And then we're going to set f prime of x equal to g prime of x. If we just type f prime of x and g prime of x, we would have both functions there. I'm going to turn off f and g. And then remember, we wanted it on the interval between 0 and 1, which is right here. So 0.67582 is the answer that we would report. You would only need to go to 3 decimal places, but I like to go to more sometimes. All right, that's it for question 2. Hope that was helpful. Thanks for watching. And if you like this video and it was helpful, give me a like and share a comment below which problem on the AP exam this year was most difficult for you. And if you're not subscribed, please do so, and you'll always stay up to date with my most recent videos.